All right, folks. Good to see you again. So we're continuing the central tendency conversation. I'm on slide 8 with median, and I just misspoke. Um, a typical season for Mario Lemieux is, according to the median, 44 goals, and that's out of an 82 game season. That is a majority of the games. Typically, he would score a goal by slim margin. I don't know. I thought of that last statement at the end. I was like, I better correct myself. But he typically scores every other game. You could kind of think of it that way, which is pretty cool. If you're not too impressed by that, just ask yourself how good your ice skating is. And then, so ice skating is the basic thing you have to do. Then you actually have to perform the tasks, which is pretty phenomenal. Mario Lemieux, awesome hockey player, probably second only to Wayne Gretzky, um, uh, at least in modern history. I put the mean of 40.59 for his data there as a point of comparison, just to indicate that different measures of central tendency may well give you different estimates of central tendency because they go about measuring or assessing centrality in different ways. But if you have skew, which Lemieux kind of does, and ironically, the skew that Lemieux has are actually the seasons where he had single digit goal tallies. His phenomenal 85 and 70, that's not as extreme from what's normal for him as these single digit ones in general. And those were actually injury shortened seasons where he literally only played 2 or 3 games. So, anyway, very impressive, the median. And then going over to the mode, I'm on slide 9. The mode is the last measure of central tendency. It's the most frequently occurring score. It's literally just the score that occurs most often. That's all. Um, Nothing too wild about it. A distribution can have more than one mode. If there's two score values that occur with the same frequency, like most frequent, if they tie for first basically as most frequent, we would call that a bimodal distribution because there's two scores who have the same high level of frequency. You could have a trimodal distribution even. So if you hear those terms, that's what it's talking about. The advantages of the mode is that it's an actual data point, and this is the only thing you can use if you have nominal data. Like if you want to count up the number of freshmen, sophomore, and junior and seniors in class, mode is all you can do from a central tendency standpoint. Or the number of men and women in a class, same thing. The only thing you can do is mode calculations, central tendency goes. And the disadvantage, though, is that it's a rough measure. Just counting up which is most frequent um, may leave a little detailed info for central tendency on the table. The preferred measure of central tendency is mean, but we need to be careful about extreme values. That's when we want to use the median at least as a supplement to the mean. So anyway, back to the mode, the example I placed on there for the Arizona Cardinals was, no, rats. I see that it didn't update. I did update the slide, I thought, for 2019, um, which they, I don't know, maybe it was a Freudian slip that I didn't, because the Cardinals only won 5 games in 2019. But at any rate, we can look at these data here, although they're a year old, and you can determine what the mode is from taking a look at it. And what is it? I think it's 10, I believe, 8, 5. It's trimodal. Look at the Cardinals being weird. So in the last 10 seasons, the number of wins that occurs most frequently are 10, 8, and 5, according to these data here. So the Cardinals have a weird trimodal distribution. Makes sense to me. They're kind of weird. We call them the cardiac cards. As soon as we think they'll do well in a game, they lay an egg. So anyway, but that's an example of the mode. A weird one, trimodal distribution. Now, in terms of those outliers, slide 11, outliers are extreme scores. They can distort the mean. You always want to graph your data first to see if there's outliers present. More on outliers and skew in the next video.